Greetings wherever and whenever you are. Very excited to be back again this year, speaking to you about the work that I've continued doing on the personal knowledge vault, which I spoke about last year. A new use case came up for this that I'm going to go into in a bit more detail, but a bit of a bio first. So I've got a background in mining engineering originally, doing three-dimensional blast simulation design, and through that kind of got involved in modeling complex systems, which has been kind of the thread that's run through my career. I currently am excited to be working for Neo4j as a customer success architect, and I'm continuing in helping out on the community front as a strategic advisor through R-Curve in the Calgary startup region. And in spare time, of course, I do lots of mountain biking, and I have the distinct privilege to play music in my daughter's band on a regular basis. So got a show coming up this weekend, actually. Diving in. So the extension to the Personal Knowledge Vault project was inspired by Jim McLeod, who it was a brilliant and very insightful, well-known person, a bit of a mentor as well in the Calgary art scene. Sadly, he passed away just a few weeks ago, but he was the one who inspired this project. I'd been speaking with him about the core use case that I had originally had for the Personal Knowledge Vault in terms of helping people with functional memory challenges, write memoirs and continue working and whatnot. And he thought that was really amazing. And he said, we've got all these incredible stories, and we've got this incredible collection that this organization that he's involved with was curating. And they've got archives in this organization that go back to 1883 that detail all of the different interactions, the inspiration for the artists, the path that the art took to get into the collection, and so on. And when he saw the work that we were doing with the Knowledge Vault, he said, "Hey, can you investigate turning this into a system that would help us make the collection and the archives associated with more accessible?" So I thought this is a great idea. So embarked on kind of extending the Knowledge Vault project into this domain. And the idea is to enable access, engagement, and contributions using cutting-edge AI, of which, of course, Neo4j is the foundation of all this, that built on the original project. So I'm going to go through a couple of the key use cases that we've now built out and extended, and this will be deployed in the institution in the next month or so, the first phase of it. So it's really exciting. So the initial use case is going to be the art in the collection has been digitized. The archives have been digitized using a very basic but powerful process using just iPhones and some students who did the work on that. We've been able to bring the documentation in and then turn it into backing information for the art that's in the collection. So when somebody comes into the collection, there'll be a QR code that the person will be able to use to bring up then all this information associated with the piece in the collection in the gallery. And they'll be able to learn about the artwork history, the artist, the provenance, and the stories associated with the art. The next phase of the project that I'm excited to show you today is the conversational AI piece, where we're going to be using powerful AI technology to take this even further. So not just static QR code presented information. People will be able to have a conversation with the gallery. As I'd mentioned, it's absolutely incredible what you can do with AI these days. And when you combine AI, large language models, and their capabilities with knowledge graphs, you can accomplish some incredible things. So as I'd mentioned, this collection has handwritten archives dating back to the 1800s. The AI, the large language models, these multimodal models that are available now are fully capable of reading even, very difficult for me to read handwriting at a very, very, almost perfectly, really. And I mean, this has applications far beyond just this one that I'm working on. It is absolutely germane for geotechnical engineering, borehole logging, applied engineering, artifact heritage collections. Like the list of potential of this type of technology is endless in terms of being able to bring archival records or records that were difficult to access prior into a place where people can communicate with it and ask questions about it. So the process here was we went in, digitized a chunk of the collection, brought them into the graph, and then started using some of the methodologies that are available and through the great work that the Gen AI team at Neo4j are doing to make this collection fully conversational and searchable. And this is the intent. Somebody will be able to come into the collection and they'll literally be able to talk to it. Tell me the story about this piece. How did it come into the collection? Show me other pieces like it. Create a custom tour for me. And it can do it in any language. So this is very, very powerful stuff. The other thing that's also very important and rather poignant, given what happened, Jim passing away, is the fact that the stories associated with a lot of these collections they're in people's memories. So the other piece of this project, once we kind of get the foundation in place that we're going to embark on, is we are going to get some of the members of this institution to record their memories that they have associated with the pieces, associated with how the collections came into the pieces came into the collection, and so on, and their experiences with it, and also talking to the artists as well. Those will be transcribed and stored as part of the curation efforts. Another thing that we're experimenting with is this idea of synthetic memories. And this is something I've been reading about in terms of, if you don't have, again, it's an accessibility thing, being able to kind of present in new ways things or events that happened where there may not be specific historical records. And you do have to be careful with this, obviously. So the intent is to take the stories and generate images associated with them, but in a way that they're, ephemeral and can be clearly identified as memories and not historical photographic facts. So the benefits, of course, to enthusiasts, it deepens the engagement with the collection and the history associated with it. It encourages intergenerational storytelling. So younger folks will be able to get these experiences and hear what and experience what people who have direct connection to the art may have. It's obviously a big learning element to this, and it's capturing our heritage, making it relevant in the digital age. Switching over to the technology side, of course, as I mentioned, there's kind of a foundational piece to this, which is the basic. You go in, you have a QR code that retrieves the associated information. That's kind of the dial tone, the baseline, and there's a whole bunch of work that needed to be done to get that functioning. And this is something that I think is extremely important and is often lost in these AI initiatives, is you have to have a good model. The model matters, and I'll talk a little bit more about this after I show you the functional demo. The model is the foundation of accurate, reliable AI. If you don't have a good model, if you don't have accurate information that's derived from archives and derived from reliable stories, the AI experience that you give people is not going to be very good. So that's where we started with this project. We made sure that we had the archival foundation in place before we embarked on starting to build out the agentic pieces and the interactions. The other piece to this too is there is a secured storage that exists in behind this system that uses an Amazon S3 compliant storage mechanism. So the brokering and the transactions that you'll see as I pull back the artwork and whatnot, there is a security layer there that is actually storing the images and the details of the collection in a way that's as per the name, in a vault. I didn't want to store these things in kind of also in sort of directly in the AI agent world and ChatGPT or these other things, because this environment with the graph database and the associated file store need to be a secured and private store that you then use model context protocol methods to connect up to the AI agents and whatnot. We are going to be using GraphReg and some of the agentic AI that's available from Neo4j to enable rich retrieval. I've got the basic elements of that functioning now, and I'm going to be extending that quite a bit further. And then there's going to be a generative side of this, where there'll be a media engine that's linked into this that will be then capable of generating additional artifacts and context for enthusiasts. Models matter, yes. So this is, again, very important. In order to really have this rich experience for people so that they can engage with collections, and this is extremely important, whether you're talking about an art gallery, whether you're talking about personal memories and knowledge, or whether you're talking about engineering use cases where you really don't want to have incorrect information coming back out of when somebody asks a question. And I often hear, wow, it's expensive to create reliable, good, solid models. And that's true. It takes work, it takes time, it takes thought. Um, but the fact of the matter is, trust is at the foundation of this. It has to be. And when you're dealing with high accuracy questions, you must deliver higher accuracy answers or you will lose trust. And once you've lost trust, it's very difficult to get it back. This is why knowledge graphs are the optimal way to build models. Building a model in a knowledge graph allows you to bring together different aspects of the data, the structured data that can denote kind of a foundation. You can then bring in the documentation from whatever source, build a graph document of that gives you a high fidelity and accurate representation of the document. And then you can enrich those data to provide categories and additional methods to help build context. That unified together creates the knowledge graph representation that is a very reliable and accurate foundation to ground a large language model into a specific domain. This is another thing I find really interesting. It's like there is a lot of really important and rich information in documents, the structure of a document. And when you're dealing with bringing documents, as we did with this project and many others that I work on and have worked on, particularly if you're talking about legal or environmental impact assessments or engineering design documents or maintenance manuals, the way a document is laid out has critical information about the context of the paragraphs and sentences inside of that document. So if you imagine what you're doing with a basic RAG and vector approach, similarity approach, is you're taking that document and you're tearing it up in little pieces that are kind of around the sentence chunks. You're putting them on the floor and then collecting them into piles using a similarity algorithm. So if you come walk in, you ask, if you ask a question, essentially what happens is that question finds the pile, or the retriever finds the pile that's the most similar in the vector database and brings back those chunks. There's no context associated with that beyond just the basic similarity. So the accuracy of your answers will not reflect the nature of the contracts. And this works okay if you've only got a limited number of documents. But some of the clients we work with have tens, hundreds, or even millions of documents that have detailed legal structures in them. And you can't have a situation where you're trying to get a legal reference out of a pile like this that may be coming from a document from the wrong domain. So that's why the graph allows you to actually contextually represent the structure of the document, have the documents well articulated in graph structures so that you can provide that context to the large language model and get accurate information to respond. Briefly, I want to talk a little bit about model context protocol and SQL cipher generation. So there are some very useful things that come out of this idea of being able to generate SQL or cipher statements from a natural language question. And certainly that has utility, and I am using it in the context of the personal knowledge vault art application and others. But this is my Westphalia, which is a really fantastic machine. It's all analog. And I've been able to, this idea of SQL generation, I'm going to use a bit of a metaphor here. It's like having a universal toolbox. And in the case of my van, I have a universal toolbox that I travel around with when I'm on the road: a hammer, vice grips, duct tape, and a couple screwdrivers. And I am able to effect fixes. And so I was driving over the Duffy Lake Road last summer, and the throttle body, which is this thing you see in this picture here, broke. And I was able to jerry-rig a solution out of that by just kind of, getting a hose clamp and sticking it on there, and off you go, which is great. That's a bit what the SQL generation stuff is like. You can usually get a reasonable query generated if you're dealing with a relatively simple case where you need to fix something. If I really need a solution to that, so once I got back, I got myself back across the Duffy, and I take the van into a proper mechanic who has real tools who can actually fully fix the thing. So same thing with model context protocol. You need to build tools and think about this idea of building out tools in the MCP context that pertain to the domain and function and can be tested, accurate, and reliable to get high fidelity, accurate responses. And I think about the model context protocol thing a bit like this. If you're on a construction site, you've got mechanical systems, electrical systems, plumbing systems, and so on. You'll have a blueprint and you'll have a foreman. The agent, the orchestrator, is like the foreman. a request comes in, they're looking at the plan, they figure out from the plan, okay, we need to execute these particular jobs. They go to the team, essentially the MCP server, that then has a bunch of tools inside of that toolbox that those experts have inside of that domain to then accurately answer questions and then execute the functions that are needed to build out the reliable systems. And in this case, the model contracts protocol agentic pattern works by, if you've got a bunch of different domains, as I do with this application, then you have reliable specific tools that operate in that domain that can handle answering those questions that come in for that domain that then the orchestrator can route properly. Don't rely on magic generation. You want to be able to have the tools tested, you want to have accuracy, and you want to have reliability, and that's how you go about doing it. So it's demo time. Yay. All right, so I'm going to start with the this first. And let me get my questions up here. Okay, so let's go. Art featuring horses. So what this is going to do, if life is good and the demo gods are with us, and they are, look at that. So what this is doing is, in behind the scenes, there's a MCP server that exists, and it's the Neo4j MCP server that's handling some of the basic Cypher query elements. It's got a number of tools registered in it that relate to talking to the primary graph database, and I'll show you that in a second. Then there's a second model context protocol server that actually is the server that has tools in it that are defined to interact with the personal knowledge vault itself. And those then are capable of getting and returning images, getting and returning details and specific elements that come out of the knowledge vault collection. So this interaction that you saw just happen there, that's several different servers participating in an orchestration inside of the agent's context. And I don't have time in this session to go through all the details of this, but hopefully we can set up another session to do that in more detail. These images that you see here are coming back at about a secured vault that's being hosted inside of Mini.io, which is an Amazon S3 compliant storage, and it is SSL encrypted. You can't get to these pictures. The AI agent has essentially context and tokens that are allowing it to do that. But you can see that the impact of this now, by just asking it that question, I'm now getting back here all the curated art form, a curated list of the art in response to my question about show me art from the collection that has horses in it. And then you can see some of the details. So let's say we want to, and you can also, the other pieces that are germane here, these descriptions that you see, there's an agent as I'm adding information into the collection through the digitization side of this. These are being generated through the agent having access to a media card and, of course, the backing store for all the data that was brought in from the PDFs. And essentially, I have an agent that says, you're an expert in art. You're an art curator. Create a story or a narrative and describe accurately this painting using artistic curation terms. And I have had a curator review these, and they're quite impressed with the results of it. And again, this works because I have built out a model that accurately represents the data, the backing store for all of these pieces and the artwork associated with them. Then we can also get provenance, the lineage of how the collection came, or the piece came into the collection. And this is also fascinating, like the way that this interaction works, and it shows the potential of it. And you can see here are the different tools that were used, the reasoning steps that are involved that the agent did. And now I want to do something more fun. Let's create a custom tour of the art for me. Of the art with mountains, because I like mountains. So what that'll do is that'll start firing off our little agent. Our agent will do some reasoning. It'll figure out a strategy. It'll go to the curation and the collection to figure out which pieces it needs to pull back. It will then, once it figures out the various different art, mountainous artworks, it will then pull that back. And what we should see is, here's our little art tour. Here's your custom tour featuring martins from the collection, a vibrant expression of Canadian landscape painting in the tradition of early 20th century Impressionism. This piece majestically captures the mountain summit, rendered with bold blues, purples, whites, and so on. There's our picture, peak of the sawbuck, oil on board. So this is our second piece, so quite a different piece. And then this is really neat. The tour highlights the different artistic perspectives on mountain grandeur, from pure exhilarating landscapes to the intersection of nature and human achievement, offering you a deep appreciation of the artists. Would you like to add more art? So, and so on. So you can continue this interaction with the gallery and the collection and everything else. I did want to show you, there was a little bit of the back end stuff. Well, I've still got a few minutes left. So this is the administrative interface for this. And what you'll notice in here, of course, is you've got the pieces, you've got the information, the basic information associated with them. And again, I can bring up the backing information. This information can then be edited and curated and modified if need be. I have the collection, the acquisition story. And again, this particular piece of information, the AI agent is conditioned to provide a summary level version of it. So the administrators who have access to this have a much more detailed information because they have all the files and behind the scenes. So this actually does have the notes and all the detailed documentation and information. Some of it is more private. So there's a security layer inside of this that allows people who are logged into it to get more detailed information, and the agent is conditioned to respond to that. So it knows basically this person has access to this information. This person is just in the gallery looking at it, so they don't get access to it. And then, as I'd mentioned, this is an example of the handwriting, and then the actual transcription of that handwriting. Very impressive. Like I'm continually blown away by the fact that these agents are able to do this kind of thing in terms of extracting arcane information. And there's quite a number of documents in here that have been processed, and they're all sorts of different shapes and sizes, all kinds of different, random bits of material. Some of them contain invoices, notes, stuff that's sideways. The agents can handle all of this now. It's without a problem. In terms of the API layer, we have the primary data link API. So this is the piece that kind of where the primary tools are all defined. And there's some interesting conversations we could have in more detail about how big is a tool. So you need to think about these tools in I think the same way that you think about API design. So when you're going to lay out your tools inside of the model context protocol context, you need to think about designing the tools in such a way that they can be tested and reliable, but you have to think a bit about the orchestration. So the tool that actually is doing that retrieval element with the pictures and everything is this one. I could have built tools that are even more granular than this for getting the art piece and the associated data back from it. But I thought about that, and it's like, no, in this case, I need this information to come back in a specific shape. It needs to come back with the URL references generated, and it needs to come back in such a way that it's orchestrated properly. I can't rely on the agent to do that for me. So in this case, human guy here built the orchestration, gave the tool to the agent, and then the agent is reliably able to execute its function. The second layer to it in this case, so this is the limited API. This one's got the endpoint in it. So this particular model context protocol server is this is the orchestration side of it. This has the MCP endpoint associated with this API, which has a reduced set of tools in it from the total set that are in here. So I've only exposed a few of these endpoints to the MCP layer inside of this MCP server. This then ties that MCP server in, and it's got a second MCP server that handles some of the query response stuff. And then secured file store, this is it here. And you can kind of see there's the primary images, and then there's a bunch of other additional metadata and thumbnails and whatnot and backing stores. And then I've also got all the files in here. They're broken down to individual images. So this is the way then that I actually handle the digitization of the art. Inside of the code base very quickly, here's your fast MCP endpoint that's got the context and whatnot associated with it. And the conditioning for the prompts. And then inside of this, we've also then got all of the workers. And just to really quickly, this is all the code that handles, this is using Celery, which is a multi-agent processing asynchronous processing architecture for Python. Very reliable, works great. We have used it on big projects, and I'm quite impressed with it because it allows you to build out nicely orchestrated, scalable processing systems. So that's what I'm using to handle when I'm pounding in hundreds of PDF files. I can scale up horizontally by increasing the number of Celery agents, workers, and they handle kind of all the ins and outs of breaking the PDFs down into the graph document structure. And I'll kind of close out here and then trying to answer a couple questions. So the graph document structure is basically like this. You've got the artwork, the PDF file. And if I expand that node, you can see there's the page that drops to pages. The pages then have chunks. So this is, and in this case, I'm only going 2 levels. If you do have more complex documents, you can get into doing additional, sections, tables, and all that kind of thing to break the structure out to give you a lexical representation of the document in such a way you can increase retrieval fidelity if you need to get to specific clauses or sections. Okay. What do we got for questions? Any questions? Oh, shamelessly requesting code to be shared. Yeah, I got a bunch of cleanup to do before I can share the code. I think, planning to do that, but there'll be some work that I have to do around so it may take me a little bit yet. I want to get this thing up and running in production for the organization before I start putting the code out there, because I do want to make sure that everything's in good shape before I hand it over to folks. Are there any other questions? Let's see. Celery is Celery is not quite like Apache Airflow. It'd be lower level than that. I saw that question in there, and it's basically it allows you to kind of build out your own orchestrations using essentially the worker patterns that are inside of it. So in this case, I've got a relatively simple orchestration. As I'd mentioned, we have used this on projects with fairly complex orchestrations, but in cases where you need to have that granular control, I'd use something like Airflow or something like Databricks to do more orchestrations that need to be managed in those ways. In this case, I wanted to have very fine control over the processing aspect of it. Database design. Yeah, the database model on this, I've definitely iterated on that quite a bit. There's actually some really great guidance in some of the Neo4j sessions. Let's see if I've got anything on that in here. Yeah, so in this case, my objective was kind of balancing out the structured, unstructured data aspects. So you do have a bunch of metadata that comes in with the artwork and whatnot. You also then want to be able to do retrieval. So you want to do specific retrieval around, I want to see, brushstroke artwork, really specific category. Or I want to see art that features horses, as I'd mentioned. Those are 2 very different types of requests. So the model that you construct needs to factor in the types of questions people are going to ask. That's what I'm doing here. So I chunked this out to a fairly granular level. I think my smallest chunks are about 500 tokens, roughly. So then when somebody asks kind of a specific question, there's a number of retrieval strategies you can use inside of the Neo4j context to cover those off. Was asked earlier, so this is a local club that's actually sponsored the work on this. They're connected to an organization, a larger organization, so that's actually in the process of doing a big renovation. So depending on how it goes with this smaller project, we'll see where it ends up. We may be looking to give this other entity a hand. But this is basically a Calgary-based members-centric collection is what it is. Yeah, they have some the archives are absolutely fascinating. It contains a lot of really unique history specific to Alberta. which is the province where I live in Calgary. And I can provide some more details about it when I'm going to do some posts on this as well. I think I'm out of time though. Yeah, so thank you for your attention. And as I mentioned, there'll be more information coming out on this project as I continue to move it forward. And I'll be answering some questions in the chat following this session as well.